2, 1.
Happy New Year.
Picture. Now, the last picture.
Right here in the video, this is a video of the bowling ball pendulum lab we did outside. So right here, I'm holding the bowling ball up above the ground, and so it has what we would call potential energy. Because gravity is trying to pull it down to the ground, that means if I let go, it has the potential to move, has the potential to turn into kinetic energy. Right? I use the energy from my body. I fought gravity to pick up the bowling ball, and so that transferred the energy from my body, some calories maybe that I ate for dinner last night. It took those calories, it took that energy for me to lift the bowling ball to fight gravity, and now gravity wants to pull the bowling ball right back down. Okay, so we have all this space that gravity wants to pull the bowling ball. So right now the bowling ball has an awful lot of potential energy. Okay, and if I were going to draw a pie chart, okay, and we'll say red equals potential energy and blue equals kinetic energy. Right now, I've got all potential energy, okay, because the bowling ball is above the ground. Gravity wants to pull that bowling ball down, and all that energy is stored. So that's all energy that is not being used but could be used. Alright, so here in the video I'm about to let the bowling ball go. And right now, like I said, we had a bunch of potential energy. And that bowling ball is going to start moving towards the ground as soon as I let go. So here I am, I let go of the bowling ball. And as soon as I let go, the potential energy that we had right here starts to slowly become kinetic energy or moving energy as it goes down. So as the bowling ball moves down, that stored energy, my potential energy that I had stored up from my body into the bowling ball, starts turning into what we call kinetic energy. So kinetic energy is energy that is in motion. So it's moving energy. And the thing about kinetic and potential energy is that they kind of replace one another. So let's say I had, and I definitely had more than this, but let's say I had 10 joules of potential energy up here. So that's stored energy. So that bowling ball had the potential to create 10 joules of energy. Okay, so that's potential energy. That means I had 10 joules stored up. Now, when I let that bowling ball go and it starts to swing down, like I said, that potential energy becomes kinetic. And down here, you can't actually see because of the video, but when it's straight down, so the bowling ball's here somewhere, it's got the closest to the ground it's going to get, and we would say that all the potential stored up energy has now become moving energy, kinetic energy. So if I had 10 joules of energy to start with that was stored, all that energy should have now become kinetic energy. Now I would have 10 joules of moving energy. Now the other thing about this type of kinetic energy and potential energy is that it has to do with gravity. This is called gravitational potential energy. So the higher something is off the ground, the more potential energy it has. The closer it is to the ground, the less potential energy. So what you'll notice is this bowling ball swings back up. There's about its highest point. Now as it gets farther away from the ground, so now look, it's way back up above the ground again, the kinetic energy that we built up has now, as it moved farther away from the ground, has turned back into potential energy. So the energy never goes away, it just changes what kind of energy it is. Okay, so here it's up above the ground, it's turned back into potential, it's slowed down and it stopped, so that means it's at potential energy. Now when it starts coming back down, it's going to start turning back into kinetic, and down here, where the ball is moving its fastest, now it's back to kinetic. So let's watch the whole thing right here. Again, so here's potential, You'll see when I let go, it speeds up. It gets to its fastest point, where it's closest to the ground, then it starts moving farther away from the ground, which gains more potential energy.
2, 1.
Happy New Year.
Potential, kinetic, potential, kinetic.
Now the last picture is when this comes back to me. Right now.
So this time I'm going to draw a little pie chart for each one. So right here at the beginning, I have all my energy stored in potential energy. So if I were going to make a pie graph and red was for potential energy, my whole pie graph would be red. Okay? Now, once the bowling ball starts moving, right here, now my pie graph, okay, you can see the bowling ball is closer to the ground. That means it must have used up some of its potential energy, because the higher it is away from the ground, the more potential energy it is. So right now it's closer to the ground, so it must have less. But that energy had to go somewhere. So instead of the energy now being potential, now that energy is turned into kinetic. So right here, if I drew another pie chart, I'd probably have about half and half. So it's not on the ground, so that means it still has some potential energy. Okay? But it's still probably speeding up a little bit, and it's still moving, and it's not going as fast as it's going to go, so we probably still have about only half a kinetic energy. And as the bowling ball continues to speed up, the amount of kinetic energy would get bigger. So as it continues, right here is about the fastest the bowling ball is going to go and the closest it is to the ground. So right here, all of our energy would be in kinetic form. Okay, and then as it starts going up, that kinetic turns back into potential. That's why it slows down. And then when it gets to the top, it stops for an instant, then it starts to speed up back towards the ground, turning back into kinetic. So the big thing to gain here is that energy is never goes away. So my potential energy that I stored up in the bowling ball when I lifted it up never goes away. It just turns from potential to kinetic. And we call this the conservation of energy. So that means that energy is never destroyed, it just changes forms. In this case, it was changing from potential energy, then it'd start going really fast, and it'd turn into kinetic energy, and then it'd turn back. So conservation of energy means energy only changes forms, but it doesn't disappear. And it doesn't magically appear either. So that's the reason that, luckily, in this video, not luckily because I knew how it was going to work, that's the reason that the bowling ball could never come back and hit me in the face, because it only ever had this much potential energy. It only has the potential to get this specific distance off of the ground. I know it can never get higher than that. So when I let it go, you'll notice when it comes back, I don't flinch. I know it can't hit me in the face
Happy New Year.
because it only has enough potential energy to get back up to this point. No energy is added. As soon as I let go of that bowling ball, there's no energy that comes out of nowhere. No energy magically appears. Only the energy that I put into that bowling ball is there. So that's all part of the conservation of energy. Energy only changes forms. It doesn't disappear, and it doesn't just magically appear. Somebody has to put that energy there. All right, so here's another example of potential and kinetic energy, but it's a different type of potential energy. So with the bowling ball, all the potential energy was caused by gravity. I lifted something off the ground, and gravity wanted to pull it back down. This time, I'm going to add energy to something that's stretchy, something that's elastic. So we call this elastic potential energy. So the basics of this one is, again, I'm going to use some of the energy and I'm going to transfer some of the energy from my body into something else. This time, instead of letting gravity store that energy for me, I'm going to let these elastic bands. So you can see here I start to pull back. I'm pulling back these elastic bands. As I'm pulling them back, it takes a little bit of energy for me to do that. Okay? That energy that I lost, though, again, it doesn't disappear. It's conserved. That means it doesn't disappear. Okay? The energy that came from me gets transferred into these elastic bands. So we haven't lost that energy. We've just kind of stored it for us. We've stored it for ourselves. So the energy that came from me, I lose the energy, but it doesn't disappear. Again, energy is conserved. It doesn't go away. It just changes form. So I've changed the energy from in my body, and I've put it into these elastic bands. Now, here in a second, the elastic bands are going to transfer that energy again, and they are going to transfer it. Okay, so right now we have, again, potential energy inside these bands. When I let go, those bands are going to turn that potential energy into moving energy, kinetic energy. So again, here's my pie chart showing how all my energy is stored. So right now it's stored potential. When I let go, let's see if I can catch it right in the middle. So right now I have potential energy. I'm going to let go of the water balloon in a second. Okay, now, right here, so I let go of the balloon, and the elastic starts to move. Okay, so right here it's all potential. In between, those elastic bands are changing my potential energy into kinetic energy. So if I had to draw another pie graph, I'm now about halfway. So there is still some potential energy because those elastic bands are still stretched back a little bit, but they're not as stretched back as they were. So I still have some potential energy, but it's moving now, right? And that kinetic energy is kind of overtaking the potential energy. So right here I'm at about half potential, half kinetic. And if I continue, we would see that the balloon, I'll try to get it right. Okay, so here's the balloon. You can barely see it here, but at this point, those elastic bands have transferred all of my potential energy that I had here. Okay, back here where I was holding it, there was a lot of potential. About halfway, some of the potential energy had turned into kinetic, but not all yet. And now by here, all of my energy has turned to kinetic energy. So my circle would be blue because blue stands for kinetic energy for me. Okay? So again, here's to start with. Starting position. I had all potential. Halfway through, I had half potential, half kinetic. And at the third position here where we can see right now, all my potential energy has been turned into kinetic energy. And we're going to see what happens. So to just kind of sum everything up, what we would say about potential and kinetic energy is that energy is never lost. It just changes form. So potential energy is one type of energy that's stored up. So right here I'm storing up some energy, storing up. And when I let go, we're going to see all that stored energy turn into moving energy or kinetic energy. Okay, and that kinetic energy continues until it hits the ground.